Welcome to the Fire Podcast, where we talk about data, AI, analytics, health tech, all kinds of other things. Today, we have a healthcare guest. I think actually, Mark, you do have a healthcare background.
But I no longer play in the healthcare space. It's very challenging, and I feel like having my hair in my head still. Yeah, you can go first and introduce yourself.
Yeah, sure. Well, hey folks, my name is Chad Sanderson. I am the CEO of Gable.ai. I'm an author, so Mark and I are co-writing the O'Reilly book on data contracts. I've been in data definitely most of my career at this point. Started as an analyst, became a scientist, then became someone who owned the data platform, then ran entire data organizations, and now I'm doing my own stuff. Mark?
Yeah, Mark Freeman joined as employee one as a Gable at Gable. Chad is quite the salesperson, convinced me to quit my job on the spot, which was pretty cool. But basically trying to solve a problem that I think a lot of us, if you're listening to the show, probably experienced is data producer and data consumer kind of challenge. And that's where kind of data contract center. Before that, data scientist turned data engineer, really where I started really, cutting my teeth on data quality and data was in healthcare. I focus on electronic health records and claims data at scale using giant data sets, Spark, things along those lines. And basically, as a data scientist during those time, I couldn't do my work because the data was just such in bad state and multiple jobs. And eventually that pushed me towards data engineering and really thinking about this from a systematic level.
Cool. Yeah, thanks, guys. I got to say, I'm honored. Chad, you've been like somebody I followed quite a bit in the last couple of years. I think this whole kind of movement of, data contracts, data products is, name of the game right now, right? Especially now that we're getting into AI, kind of replacing a lot of the traditional data work. People are really starting to understand why you can't treat data as just a back end function, and you can't build any data products without involvement of the whole business and SMEs and stakeholders and all that. But I'm sure we'll get into all that. But yeah, so maybe we could start off as like, how did data get so bad? How did we get here?
Yeah, I can go for that real quick. So for me, I feel like, think about the history of data. There was a point in the world where data was very thought of as part of the infrastructure of the business. Think about the data warehouse world. Think about late 90s, early 2000s, where you had data architect, it was on-prem, and people thought, I think clearly because it's such a huge investment into having these data capabilities, right? And then fast forward, you had the cloud come up, and you had data lakes, which really fundamentally changed a lot of the incentive structures of business for this. It moved away from, well, let's have this data set up or make this huge investment to what's speed to market? How can we iteratively build really quickly to that? And that wasn't available before. And then with cloud, you spin something up over minutes and you had your infrastructure, right? And you're just throwing data into there. And so this data component really started becoming this lost art. And so I think that's kind of the impetus of us getting to this position was the incentives changed. You now had to basically push as much data as possible into a data lake, which were really great for machine learning, all these other things, but then became kind of a bad, dirty habit where we just throw in the data lake and figure out later and not really put much thought into it. And I think that was okay. People got to market, they got their data infrastructure. We started seeing all these things pop up, right? But now we're getting to a point where the data aspect past that replication is now starting to become more mature. It's becoming data products, becoming machine learning models with LLMs and AI. It's becoming even more important where it's now being pushed back into the product again and faced by everyone. And so I think that's like the historical context, but I think Chad can probably provide more of the stakeholder context as well, like what's been happening.
Yeah, I think Mark said it very well. The short answer is that we moved from a centralized world of data management to a federated world of data management. That, I think, is the byline, where a small number of teams were responsible for architecting a data environment that was designed from the ground up to solve some very particular set of problems, to a totally federated environment where the data was a byproduct of producers who are building systems and operational databases and so on and so forth to solve some completely separate business problem. And the data teams became more of these aggregators. Like that was our job. It's like, well, let's pull all this data together and see what we can make of it. And I think that in the 2010s, when we started to see the big shift towards the cloud, the analytical database vendors really did something quite novel. by separating compute and storage. So your Snowflakes and your Databricks and your BigQueries and so on and so forth. And that was super innovative technology, got folks out of the on-prem world or thinking purely about on-prem away from the verticas. Then I think there was another sort of revolution when it came to data movement on two fronts. You had the whole ELT paradigm that emerged. So instead of doing all your transformation up front, you load your data into your analytical system, and then you do your transformations there after the fact. And that sort of made sense, I think, for this new federated environment. You're just pushing the workload onto the analysts instead of having the teams up front do it. And then you also had streaming. So instead of having these very long batch processes, you were trying to get data in the form of events as quickly as you could from a producer to a consumer so that you could make real-time decisions. I like to think about data infrastructure in general in three main layers. The first is your sort of database compute storage layer. The second is your data movement layer. So that's all of your transformation tools, your ELT tools, and so on and so forth. And then the third is your data management. And data management would be things like data quality, data governance, data cataloging, and so on and so forth. And I think this is where the problem is, right, today. It's not like we have the ability to store a bunch of data and it's not super expensive. We have the ability to move data around, and that's fine. Like, we can do those things. But when it comes to understanding what the data means, who has access to it, is it high quality or not, this is, I think, like the final barrier that is really keeping teams from getting a huge amount of value from their data. And so the question is, well, why does it seem like these other two layers have innovated into the era of the cloud and into the era of federation where data management didn't? It seems to have not done that for whatever reason. And my belief is that we've effectively taken a very old school approach to data management, data cataloging, for example, that was really like the catalog was designed around the concept of a library. You know, like you go to a library and you get this big list of all the books in it, and the librarians come and help you and they manually fill it all out. And we've basically taken that, which made a ton of sense for the old Vertica days when everything was on-prem because you didn't have that much data. And because you had data stewards like librarians who were helping to keep track of all these things, it made total sense in that world. And then you've brought that thinking to the federated world of the cloud, where there is no one who is actively doing all of this. You've got so many producers, so much data coming in, so many different ways data is coming in. Well, how could you possibly have any group of people manually trying to keep track of all that? And the same is true for quality, and the same is true for governance. So I think that the modern quality solutions, the modern cataloging solutions, they were built in the cloud, right? They're built to take advantage of cloud technologies, but they haven't fundamentally changed from a centralized approach to a federated approach. And I think that's why data organizations in general have had this cap on getting value from data. That's my perspective.
Awesome. Is your take that federated is the same as a data mesh?
No, I don't. I think that if I were to use sort of an analogy, I think that having federated engineering teams is sort of like the high level goal. The process or the organizational model that you implement in order to get there, if we're not talking about data mesh, if we're just talking about regular software engineering, could be agile. But then you could also have technical implementations and technical concepts that you put in place to get there, like microservices, for example. Like microservices is what truly allows engineers to write code in a very federated way. And then you have tools that facilitate this as well, something like a GitHub, because a GitHub allows you to actually push code in a federated way. So all of these systems, right, the model, the way that we actually write our software and how we govern our software, that vertical slice is federation to me. And so data mesh can certainly help you get towards federation, but you need everything to really drive you in that direction.
And something I want to add to this, and especially as we've been writing the book, our understanding of what is data and metadata has evolved. I think data mesh is really rooted in the traditional sense of data and domains and products. Where we've been really focusing on is actually like, where is that definition of data actually expand? So it's not just the data and data tables itself, but it's like the code that informs data, the events that informs data. There's so much to it that I think by only focusing on the one slice, you're missing out on the rest of the business that is actually producing the data that's going to be part of that domain.
And maybe to elaborate on Mark's point really quickly, because I think it is such an important concept, and it is something I believe that data mesh actually doesn't, I wouldn't say that it gets wrong. I would just say it doesn't fully account for, which is when we talk about data, normally what we're talking about is materialized data, right? A row of realized information that exists in some downstream system to be consumed. So it could be a table, it could be a column, it could be a file, right? When we're talking about data, these are usually the things that we're talking about. But when you're talking about data management, and especially when we start thinking of what does it take to manage data in a federated environment, you have to think about all the players involved. And the players involved are not just the people who manage the materialized data. They're looking at the tables and looking at the columns. There's this other group of people as well. And those are the producers of the data. And it is true that just like in any other software engineering environment, they care about logs and they care about traces and they care about understanding what is being produced. But 90 to 95% of the time of a software developer is spent looking at code. It's not spent looking at the output of their code, right? So they're thinking about GitHub, they're thinking about CI/CD and testing and unit testing and integration testing and these like sorts of things. This is what is and design, right? That is sort of what's a part of their day-to-day environment. That's where their life is. And what data mesh kind of asks these guys to do is to bring them out of that world and say, hey, you guys in software engineering and code world, stop doing that and come over here and focus on data world, right? Focus on the tables and the rows and the columns and creating processes around that. And that is a tremendous operational burden because we know that data teams can spend their entire careers doing nothing but that. So now if you're a producer, you now have the responsibility of doing all the stuff on the code side that was already a full-time job that you're probably behind on. And now also all the stuff on the data side, which is also a full-time job that another group of people is spending all their time on. And when I have seen implementations of data mesh go awry, it is normally comes down to that. It's just not what people saying. People just don't say that's the reason, right? It's like, oh, well, I'm facing friction and pushback from our producer teams. And it's usually because of the cost, right? The cost burden. But that's the approach that most folks normally take because what is the alternative, right? What is the alternative to caring about data if not caring about the tables and the columns and the fields? And what Mark is referring to is we actually think there's another way that is more aligned and actually more valuable. And the long story short of that is that every single piece of data that ultimately gets consumed in some way, shape, or form goes through an engineering system. It was either produced from an engineering system, it was produced directly from code, it's either transformed by code, it was ingested in code, like somehow it's got to get into the system. And there's a person that owns the code that is handling the management of that data. And where you want ownership to first and foremost is right there, right? Is to be able to tell a software developer, you own code that ingests, produces, transforms, enriches data in some way, and you are responsible for those set of operations. Now, there's a whole lot more that we could say about that, but that I think is a very different approach than what sort of your normal data management sort of organizational processes talk about.
Yeah, I mean, you mean it's not just like a one-time thing where just like you create a whole bunch of ETL scripts or pipelines that get created. Oh, just load that bunch of data. Here's a CSV extract. Just go ahead and load that for me. Boom. Nobody maintains that, right? It's just the only kind of like most data teams, even if they have an SLA, uptime, they monitor uptime, they monitor if we got the latest file. Nobody's monitoring the code itself that's loading that or just transforming the data that's transforming the date, whatever the date is that's being used, that's truncating the month. So the date becomes corrupted or something. And then downstream, years later, somebody discovers it's like, shoot, all the dates are wrong. How do you fix that? How do you fix for something like that? And then how do we get away from the just load some data to like, hey, this is how this drives revenue. This is how this drives the whole value of the business. How do we get to that point?
Something I think is really kind of fascinating to me when doing research for the book and then also talking to these producers more than on the data side is how much we take a data perspective to them. And I think that hinders us quite a bit. And if we actually take from the producer lens What's actually happening is one assumption I had that ended up being wrong is I thought maybe software engineers just didn't care about data or they didn't have the data skills. That's actually wrong in the sense that they work with databases all the time. They work with data all the time. They think it's integral for their role. I even talked to software engineers. They said the data model is very important for development further on later on when they want to actually build services on top of it, right? So they obviously care about data. What they kept on pointing to was they are not incentivized to work on that. Leadership and pushing out other features, they have to work on the code. And even though it is a priority, among all the other priorities, it's the lowest among them, right? So they do care, but it's not incentivized by leadership. Coupled with the fact that many times they are completely unaware that the data is even being used downstream. So they may think it's just some weird set of logs, and then a data team downstream takes on dependencies and they have no idea that's happening at all because we're siloed in these two different kind of worlds, the OLTP and OLAP worlds. And so what happens with that is that also software engineers have an understanding of the term of a contract between their services. They're like, hey, I'm going to be a service that depends on you. Do you agree to that, right? They have that already in place. They're not doing that with the data team. And so this has been a roundabout way to answer your question is like, there's this discoverability piece. This is why we focus so much on the metadata and how it connects to each other. How is your data actually being used in the real world? There's what you expected, and then there's the reality of the business. That I think needs to be surfaced. And right now it's only surfaced for the software side by itself and the data side by itself, but not together. So I think that's the first piece, right? And then the second piece is then, all right, now that you know how these connect, among all those connections, what are the most valuable? And that's what we call kind of those tier one data products. Chad's also been thinking deeply about this as well. So I'm curious, his opinion might be more evolved than mine.
Yeah. So I think the question was interesting, which is how do we kind of move away from these debates on ownership and quality and governance and move more towards something which I think is more interesting and more valuable of like, well, how do we utilize all this great data that we have and do meaningful things with it and make the companies that we work for a whole bunch of money? I think one big problem is the lack of self-sufficiency of data teams. In the software world, you have the ability to go off on your own with a small team of engineers and with nothing else, with no other dependencies, effectively go build something that makes the business a bunch of money. Data teams can't do that, right? Definitionally, we are relying on stuff that has been created from someone else in the organization. And this is like the crux of our problems is, right? Like we could do amazing things. We can generate insights or do experiments or build a machine learning model or whatever it is. But at the end of the day, I am totally reliant on whoever is giving me that data. And if that data were to change in some way, or if the quality were to lower, it impacts my work. And the way that I've been thinking about this lately is that most businesses, especially in the age of software engineering, they like to think of their engineering org as being decoupled, right? This is a word you hear come up all the time. We have to be decoupled and very fast moving and iterative and yada yada. But that's not actually real. Like that's not a real thing. There is no system. There is no engineering group in any company doing anything that is fully decoupled. Like no one is an island. We all have there's sort of connective tissue between all of us. And it is a mesh. And the way I like to think about the mesh is not necessarily as a data mesh, but it's closer to like a code mesh where your nodes are repositories. And these are the objects where engineers work. Data engineers work in repositories and software engineers work in repositories. And what are they generally doing in those repositories? Well, fundamentally, they're moving data around. Like that's kind of all software is you're bringing in some data from somewhere, you're doing some things to it, and then you're moving it somewhere else. That's what an application is fundamentally. So those are your nodes, right? Is all these different teams that's kind of doing stuff. And if this is a graph, what are your edges? Well, the edges of the data movement, right? If I have an API and that API is being consumed by some other service, I'm moving data from one system to another system. I might be pushing data to a database and then CDCing it downstream into whatever. I might be using Kafka and sending events, but either way, I can think of my entire organization like that. My whole technological infrastructure really is a mesh where the nodes are doing data transformation and the edges are doing data movement. And I think that until the broader business actually understands that and they understand how their systems are connected via data, it becomes very hard to help anyone else sort of figure out like why it's important that different teams need to take ownership of the data that they are generating, or that you need to have quality over here and you need to have more governance over there. I've been referring to this as the map. Your sort of map of code doesn't exist. And so because of that, everything looks like an isolated project, but it's not, right? And once you understand that everything is not actually an isolated project, that it's all interconnected, you start to make some very different decisions. And in fact, in the same way that Mark has been talking to software engineers, I've been talking to engineering leadership. This is exactly the thing that engineering leaders really desperately want. There's a whole avenue of decision-making that they are not capable of exploring because they don't have this map of how the systems actually connect to each other. So as an example, a couple weeks ago, I was in Spokane, Washington, which is like on the east side of Washington State. And I was meeting up with a friend who's a VP of engineering. They were doing a conference out there, and they were talking about some of the projects that they wanted to do. And one big project, this is an pretty old code base, around 15, 20 years old. They had no idea what the data model really was, right? Like, how many times have we defined the concept of customer in our code base? What does that even mean? Who is consuming these? How are we using that information? There was a whole problem around like, well, I don't even know what APIs are being called by what systems and why. Do you have redundancy? Do you have a lot of the same sort of metrics being computed over and over and over again? Do you have a lot of the same processes being computed over and over again? It makes migrations incredibly hard, right? Like, people talk about it all the time. Oh my God, we've been doing a migration for the last 2 years or last 3 years. Well, why is that? Well, that's because you have an engineering system that's consuming from another engineering system. The cost is not building the new thing. The cost is figuring out what is consuming the old thing, right? That's a data problem. It's a data management and data lineage problem. And so you have all these like problems that have emerged over time that are actually super top of mind for engineering leaders. And if those problems started to be solved through a data first lens, I think it would completely change the way the entire technical organization thought about data, talked about data, and invested in data. If data was a tool for understanding their business, if it was a tool, not just insights, right? Like that's one thing. But if it was a tool for actually understanding how your systems are tied together and where you need to be making engineering investments, it becomes one of the most important things that you can invest in your company.
Yeah. As I'm thinking everything you said, so just processing all of that, I think what stands out the most is that I think you are seeing now this demand for someone figure out a better way, right? Like, I think you're just talking about your book and meeting with industry leaders from, I think you guys are working with all the major companies out there. What is driving that demand? Like, is it really just like that we can't do it the same way we've done it before? Like, I know that, there's been a lot of changes in how, data is consumed, like just in probably even the last 2 years since the advent of, pretty much commoditization of AI systems, right? Everything is now a prompt, right? Everything, but you're nothing without data. Either you're feeding that as what you're training the model on, or you're feeding that data into the prompt to analyze it and give you solutions, creating data products. What is driving that? Is it AI that's driving mostly? Is it mostly just that the people are just, they realize that the old system just doesn't work? You can't treat data like it's hire a bunch of administrators, build some giant data lake, dump a whole bunch of data in it, and off you go with engineers just going, grabbing what they need. Like, that just doesn't work, right?
I think you've got a set of headwinds and tailwinds. So I think AI, as you say, is definitely a tailwind that is pushing engineering leadership at these companies to think differently about data in a couple different ways. I think one way is agents. This is huge. Every single company would love to have a million little AI agents, unleashed upon the code base, building features and doing all these interesting things and enabling their product managers to just write vibe code and away they go and build a whole bunch of services. Why is that not really happening today? People will say, yes, AI is writing a bunch of code. That's true. But AI is not building the types of things that you really need it to build in order to have this tremendous efficiency cost, this tremendous efficiency savings that everyone wants. And the reason for that is all these AI systems are trained on what's going on within a code base, right? So that's why they're really good at writing unit tests, for example, because they've seen examples of unit tests being applied to every scenario under the sun. They're good at that. What they're not good at is the problem I was just talking about a second ago, which is, well, if I build this brand new service, or we do so, or we want to create this big piece of a thing that needs to sit within a larger system, what are the implications of that on all the other systems that need to consume it or read from it or write to it or talk to it, and so on and so forth? This is what previously has been people cost, right? A human being had to sit down and think about how all these different things are going to be interconnected. How does our payment service connect to our customer validation service? And then the data from our customer validation service ultimately flows into our CDP or whatever. Like, some architect needed to be able to think logically about all of that, and none of the information these systems are actually connected, and in what way exists anywhere that a LLM and agent can actually consume. So having the visibility on how all these things are tied together via data, right? What is the data flow, if you will, isn't there, and that has been inherently limiting for a lot of these AI platforms. And even the big Anthropics and OpenAIs of the world, they will admit that this is a limitation, and one that they're actively trying to overcome. So that's certainly a tailwind. I think one of the big headwinds is that, I think it's two things. I think the first is there was a tremendous investment in data in the cloud, into the Snowflakes and the Databrickses and all these different types of things. And I think that the ROI of that investment in many cases is not playing out the way that these companies expect, right? They think, well, if I just store a bunch of data and I pay millions of dollars for analytics and analysts, then I will get value, right? I throw all my data in, I throw analysts at it, and profit comes out the other side. And that's not true. Like, there's just so much more work that goes into it than that. You need to ensure that insights are actually good and quality, and you know what things mean. And one of the big barriers to getting all that valuable, to getting that ROI out of the data, is the time cost that it takes people to understand what the data even means or how to use it. I think the number I saw from the data science was like 75% of their time is spent on validation, right? So it means for every data scientist you hire, you're only getting 25% of their time actually building out models, right? And so again, that hits that ROI number by hits the ROI massively. And then the last thing I would say, sort of maybe on the level deeper than that, is I don't think the data management solutions that have been built and adopted are working. I think the teams that invested in data catalogs, for example, over the past 8 years that data catalogs have been a category, are not happy with these tools. This is what we see sort of over and over again. Someone will buy a big cataloging tool, and then 6 months later, nobody's using it. Or a year later, nobody's using it. Nobody's filling it out. None of the metadata is actually being updated. Or it is, and this is like a full-time job of a group of people. And if those people leave the company, well, then there goes the utility of your data catalog. And it's the same for your data quality tools and everything else, where managing quality has become a larger cost to the business than the data quality problems you're catching. You're spending 50, 60% of your time addressing the thousands of flags that go up in a day, or the thousands of alerts that go up in a day. And either it falls, it just falls into this wayside because you're getting pinged too many times. So you start getting alert fatigue. Or it's such a cost to try to deal with the issue because it started and originated somewhere upstream that people just start to ignore it. And they're paying hundreds of thousands of dollars and millions of dollars on these tools, and they're getting burned. So I think it's a combination of all these things, right? People want better data management. They want to be able to unleash their LLMs on the code bases. They want to be able to do more with their data. They actually want this ROI. They don't want to be paying $100 million for Snowflake and getting nothing out of it. And they're acknowledging the current crop of tools isn't working. And so they're going out and searching for answers.
One thing I would add to there as well is I think the perception of data has changed dramatically. It's finally catching up with the adoption curve. For the longest, data was seen as kind of you're the insights and dashboards people, cost center kind of thing. And us being in data, we know it's much more than that, especially the productization of data, where there'd be insights within the product or machine learning. But many times that was, kind of sequestered to only the big FANG companies, the Microsofts, the Googles, the Netflixes, things along those lines, where they had the talent and resources to do these big investments. Well, the ability to put a machine learning model in production or just even AI in general has been reduced to an API call, which is just obscene. I still think about the NLP kind of model I put in production at a previous company, and 3 years later, LLMs would do that very well, if not way better, in a matter of days instead of months, right? It's not to say that this is easy to do now. It's still a challenge, but it's much more accessible to way more businesses. And now we're starting to see this perception of data move beyond just like reporting and dashboards to actually being products that many businesses can actually do themselves, and not just be the big tech companies, right? And so I think that changes the incentives as well. That is forcing people to start wrestling with these data questions that we've already been dealing with a long time, but now the rest of the people are catching up because they're starting to see the value of data.
Awesome. Question. There was a discussion I saw on LinkedIn recently that was like gathered a bunch of responses, and people were talking about how you can't do agile if you're a data team. What are you guys' thoughts on that?
It was you can't do agile as a data team.
Like you can, but it's difficult to do agile as a data team because of just inherent differences of, what a data team does and how to align that with, like you're talking about discovery, learning, iterative kind of like production of data where it's not once and done. Like you can't do like, we did this pipeline in a sprint, move on to the next, do another pipeline in a sprint and just be done. Like I wish that was the way that data teams work, but they don't, right? So data changes. It's like a living, breathing thing too, right? Like, and how do you, everything you're talking about where it's critical to the business and being treated as a product and, growth of this institutional knowledge around this data. How does that align with how software engineers usually build? Like you have your scrums, you have your agile, like how does that align with traditional way data teams are doing? Is it something you can?
Yeah, it's a great question. I think that's probably true. I think we probably can't be agile in the traditional sense. And one of the main reasons for that is that agile, like software engineering in general can be very built for purpose. So someone can say, hey, I want to build a feature. I've done some customer research. They can lay out the requirements of exactly how to build that thing. You then go out, build the feature and ship it to production. And then it either works or it doesn't work. Whereas data is more about the process of discovery. You're asking questions, and then the goal is to answer that question. And maybe that question doesn't have an interesting answer, or maybe it does. And once you come up with the answer to the question, then you can flow into the traditional agile process, right? Now I've got an answer. I can decide what to do with that information. I can go and build something fit for purpose, whether it's a dashboard or whatever it is. But there's this sort of first half that's really about sort of discovery and looking for information, understanding if the information is there, making sense of it. And then I would say that there's another problem on the back half, which is as a software engineering org, like I said before, you can basically be self-reliant, right? You don't really have to worry about something randomly changing that you built unless you changed it. Whereas in the data world, like you do have to do that. You can't just build a thing and then walk away and move on to the next thing. Like you actually have to understand that this, as you say, this is a living, breathing system. The data is always going to be changing. The upstream systems are always going to be changing. And you need to have some vehicle, some mechanism of responding to that. I actually don't think this is a purely data problem. I think that there is this dynamic between a producer and a consumer that is not really thought about that much within the agile development framework. These are not really terms that people talk about, but this is absolutely essential to working in any technology company. Is you've got people who make stuff and people who use stuff. That is cyclical. The people who make stuff produce things that the people who make stuff use things consumed by the people who use all the stuff, and the people who use all the stuff then generate insights that is consumed by the people who make things. So you've got this really interesting sort of cyclical effect. And I don't think that has been incorporated into whether it's agile or any other sort of methodology. I don't think that relationship has really been incorporated in. And so you almost always see a bias in one direction or the other, right? You always see something that sort of favors the makers. You really don't see something often that favors the users, frankly. But I think that's just because the makers are ultimately ones that are generating the very direct sort of bottom line dollar value for the business. And so you usually bias in their direction. But I think that's the big change that needs to happen. If these organizations stop thinking about themselves in silos, right? I'm just kind of this isolated maker, and I'm actually part of a broader system. So what does that look like, right? To be tangible and not fake. I don't think there's a very good change management process in the data world. So for instance, if I am building a new feature as a software engineer, there's not really a great uniform process across the board that helps the teams understand, how am I going to be judging the success of this feature? What is the data that is coming off of this feature? How is that data actually going to be designed? Where is it going? Who are the people that are going to be using it? And understanding that and mapping it out is actually a part of the development process. And then there's a feedback loop from the consumers to say, hey, here's the things that you told me that I was going to get. Did I actually get those things? And here's what I'm doing with it. And then do the producers know, are they now aware of what their consumers are doing with all of the data so that they can refine their processes and build more interesting, useful things, right? That is like a tangible example of a workflow, of the cyclical workflow that could exist in every company, but just like doesn't today for a variety of reasons.
Absolutely. Mark, you have a take on that?
Yeah, I think one thing that I think apparent when you work with code versus data, code's very deterministic. Does it compile? Yes or no? There is a lot of complexity, so I'm not to simplify it only to that. On the data side is, does my code compile, and then does the data look actually correct? And that added complexity, I think what really happens is the rate in which code degrades is so much slower compared to the rate in which data degrades. And so living with that constraint is that you can't really be agile if your foundation is changing every other kind of day with that. And I think that on the software side, they don't really have that problem until now, which is going back to your previous question of like, well, why does software care about these data things now all of a sudden, right? Is I think as we move towards kind of LLMs and agents being embedded within products, that just definitely within the software side, they're moving from a deterministic output to a probabilistic output with these LLMs. And it's completely kind of changing the way they approach building software in that direction. There's definitely still the traditional kind of software stuff, but I wouldn't be surprised as the LLMs agents kind of get more kind of sophisticated and more mature in their adoption. This is going to be a hot take. I don't know how true this is, but maybe agile won't work for software engineers who are very focused on LLM focused product, right? Because of that kind of root problem of you're moving away from deterministic output that you can rely on and build really quickly on.
I think the thing what I would say to that is, yes, I totally agree. This is more of a yes and. I think software engineers do really struggle from this problem. I think, though, that the way that they have solved this, I think you actually framed it really well, which is like modern day code quality doesn't care about output, right? Yeah, I'm going to build a new API and I build a service that has those APIs and I run all my tests to make sure that my code still works. But did I change what's coming off of that API in a way that could be bad for someone consuming it? That's usually not a part of my testing. And so what does that lead to? Well, it leads to things like someone says, hey, we're no longer processing payments in our company. I don't know why, because I didn't change anything. And so what do? Well, this is the triaging process, right? You get 5 teams in a room. You say, who made a change over the last week that could have affected this? You go through this big list of PRs. Root causing takes like 24 hours, 48 hours, 72 hours, whatever, even if it's a business critical issue. Well, what is underlying all of that is that there is some data-oriented connection between the change that occurred and the problem that happened. Like if there wasn't, nothing would have happened, right? Because these systems are not connected to each other in some way, but they are connected, and they're connected through data. And so because you don't have the same techniques on the software engineering side that you have in data engineering land, that the engineers have built up this whole set of manual processes to deal with these things. And they've written it off as like a cost of doing business. And it's not. It's a failure of data management. And I think that as like organizations are trying to go faster, as they're growing, they're looking for solutions to this problem of complexity. What used to be purely an enterprise problem is now not only an enterprise problem. Even smaller companies are facing this as they're trying to move faster and use AI, blah, blah, blah. So I think it's a double-pronged thing. It's like these issues have been around for a long time. They're starting to get really, really bad. And also, as companies are starting to shift left, there used to be folks, and all they did was think about these things. QA people, this is what they did, right? That was their job. is you would make sure that all the systems that the thing was touching didn't blow up. Now you've got SREs that are starting to think about stuff like this. But the more it sort of moves back further and further back and becomes a responsibility of the software engineer, the more it becomes like impossible to solve unless you're spending all your time on it. And I think this is where tools and technology and new systems that adopt this like data first mentality are really going to help solve the problem.
Something to add to that real quick as well is something I find really interesting is with this new perspective of these software problems being rooted in data, start looking at major outages and the root cause analysis reports typically written by software engineers and that side of the org. You start really seeing that data component. Where this really clicked for me is that I know about a couple of months ago, the whole internet went down where you couldn't log into various things. This Cloudflare had an outage. Cloudflare's infrastructure for a lot of the underlying kind of websites. Well, what happened was a software engineer changed the underlying data model, which prevented authentication of users. And so new users or people who had to log back in couldn't anymore. People who were already logged in had the cache and stuff like that, and they could stay in there, right? And so that's clearly a data problem. You changed the way in which your user is represented and in which they ask for authorization, and it no longer works because the system can't account for that, right? And so I just argue, like, if you really want to start seeing this, start looking at these major outages and the root cause analysis reports, which are typically all public, and you can start seeing that lens be applied and be like, why we've solved this in the data world, right? We can help you here.
Yeah, I think the best analogy I can sort of think of is like, imagine we spent 50 years figuring out how to make people successful in a car, right? You've got an engine, there's like a motor, there's a steering wheel, that you have to be able to brake, right? You sort of figured out all these things, and then you kind of have to for like compliance reasons. And then maybe you go and look at a plane, or you look at a boat or something like that, and people are driving without steering wheels, or they don't have engines, and they're still rowing manually. That's kind of what's happening in the data world. Like, everyone talks about, oh, we need to bring software engineering into data, and we need to be more like software engineers. I think it's the other way. Well, or at least I think the other way also applies. We've learned things over the last 20 or 30 years about how to manage data. To Mark's point in the beginning, engineers are spending most of their time, a huge percentage of their time, managing data, whether it's in a database or an event or data flow or transforming data or enriching data or whatever it is. And they're not using these techniques because there's never been anything that bridge those sides together, right? To say that the same techniques apply in both cases. It applies to your stuff and it applies to our stuff, and it has totally different benefits. And what I think is like, if that gap actually is overcome, right? If you're going to producers and you're convincing them that they need to use data techniques, not to help out data teams, which is usually where we come from, like selfishly, like, hey, do this thing so that I get better quality data. But you say, you need to do this thing so that you have better quality code, so that you are able to write and ship code faster. That is the thing that actually leads to adoption 5 times faster, 10 times faster. And the ultimate outcome of that is higher quality data for us, right? So it's sort of a roundabout way of, but I think this ultimately aligns with what data is in general. Like, data is a byproduct. It's a byproduct from a producer. So why is the way that we've been trying to solve the data quality problem up until now is forcing the producers to not treat it as a byproduct, right? It's to say, hey, I want you to make sure that this is extremely high quality, fit for purpose data that I can use and treat as a data product, when I think really what we should be saying is, how do we improve the quality of the byproduct? Right? We're not going to change what software engineers are doing. They're not going to change their lives for us, but they will change their lives for themselves. If they can write better software, if they can generate more value for the business, they'll do it. And that's the approach I think we need to take ultimately.
Yeah, fantastic. Bravo. So anybody that wants to check out more, I think, can go check out your guys's, I think you have a website and the book and the YouTube channel and all kinds of other stuff that you guys can share for others. But this is all like music to my ears. And I think, like, especially Mark, you will agree with me on that. From being in healthcare, we are at the ultimate mercy of the producers more than anybody else, right? And so right now, like, some of the biggest issues in the country, like front and center, CMS just released this whole new initiative for interoperability framework because as a country, we've invested so much money into it, and still interoperability is not there as much as you would want it to be, right? So we're seeing an increasing emphasis on that. And I think that your advice that basically treating data as a part of the value chain that you're delivering from the beginning, not as a something you come back to, but something you start with, treating it for the purpose so that it's fit for that purpose, I think is the most important thing. And we see that in healthcare because all of the issues we see are because the producers, the variability, the different workflows, and we know we're not going to solve that, but I think that there's principles that we can apply so that, data is treated as an asset. Data discovery is super important whenever you use data before you build anything, right? A data product is just as important as the feature that you're building onto your application or software product, right? And then everybody has to be part of that understanding. You can't leave data people will take care of that, because that doesn't work. So kudos to you guys for being the agents of change in this case.
Thanks, and thanks for having us. And also just to quickly highlight too, if you want access to the book, you can download it for free at Gable.ai and then /data contracts book. There's a link to it. We just want people to kind of see these ideas as much as possible. And we're wrapping up kind of like the full draft of the book now. So you start seeing the earlier things, and then the actual print production should be coming out in a few months where we really detail a lot of these ideas.
Awesome. So Gable.ai.
That's it.
That's the website.
Awesome.
You'll see a big old link for O'Reilly book, and then you can download it for free.
Awesome. All right, gents, thank you so much for your time. And it's been a real pleasure, honor, Chad, to see you, push the envelopes on this stuff. You're one of the leading voices, so don't stop.
I won't. Thank you. It's been great being here.
And
Thanks,
thanks
Gene.
Mark.